What's up, team? Today we're talking about equations of lines, specifically as they relate to parallel and perpendicular lines. So you see the learning target above. I can write the equation of a line that is parallel or perpendicular to a given line. And then I have the slope-intercept form there and the point-slope form. We're going to review both of those here shortly, so don't trip if you don't remember that stuff yet. Okay, here's slope-intercept form. This is probably the most common way you're ever going to see a line. I imagine you remember this, or at least familiar with y equals mx plus b. This is the equation of a line where x is the input, y is the output, of course, m is our slope, and b is our y-intercept. So if you're given some information, like say you have a line with a slope of 5 and a y-intercept of 2, you would say that your m is 5 and your y-intercept is 2, and so you just kind of plug and play here, y equals 5x plus 2. This is the equation of a line that has a y-intercept of 2 and a slope of 5, or 5 over 1. Okay, let's talk about point-slope form. Point-slope form is a little more awkward, a little more uncomfortable, a lot less common, although it's much more powerful. If you understand point-slope form, you're in a really, really good spot. The point-slope form is probably the most powerful form of equation that you can come up with in terms of writing lines. So the way it's written is y minus y1 equals m times x minus x1. And the things here, m is still slope, m is always going to be slope. And then this x1, y1 is some point on the line, the coordinates of some point. It doesn't matter what point it is on the line, you can pick any point on the line and plug the x coordinate in here, the y coordinate in here. The thing that makes this so powerful is, again, you can pick any point and the slope, whereas slope-intercept form, the one that we just talked about, you need the slope as well as a very particular point. That very particular point is the y-intercept. So for this one, you could use the y-intercept, but you could also pick any other point, so it's so much more powerful. Let's do an example real quick. Okay, say you're asked to write an equation of a line that has a slope of 1/2 and goes through the point 8, 11. And well, you know that since you have a point and you have the slope, you can use point-slope form. So let's just plug and play here. The y is going to be y. The y without the little subscript is still going to be our output, so we're going to leave it as y. The y1 value, however, is the y-coordinate of the point from our line. We know it's x and y, so ours is y minus 11 equals m. m is 1/2, that's our slope, times x minus x1, in this case, is 8. So this is the equation of a line that has a slope of 1/2 and goes to the point 8, 11. Okay, big example, here we go. Line A has a slope of negative 2/3, has a y-intercept of 4, write the equation of this line. So we know that if we have the slope, we have the intercept, we're going to use slope-intercept form. So it's going to be in the form of y equals mx plus b. We just need to plug in the pieces. So for us, we have our m, we have our b. So it's going to be y equals negative 2/3, because that's our slope, that's the m value, x plus b, in this case our y-intercept is 4, so it's going to be plus 4. Here's the equation of the line that has a slope of negative 2/3 and a y-intercept of 4. Okay, let's build on the same example. So here, line B is parallel to line A, and line B has a y-intercept of 7. You are asked, or what we're going to do now is find the equation of this new line, line B here. So we know that line B and line A are parallel, so that's a huge fact. That means they have the exact same slope. So our line that we're about to create an equation for has the same slope of negative 2/3. That's a big deal. Now we have a y-intercept of 7. So the equation of this line is going to look super similar. It's going to be y equals negative 2/3 x. It's identical so far because they have the same slope. That makes sense. But instead of having a y-intercept of 4, this one has a y-intercept of 7, so we're just going to add 7 like this. Let's build a little bit more. Line C now. Line C is perpendicular to line B, and line C has a y-intercept of negative 3. So we're going to write the equation of this line. Remember, perpendicular lines, the slope of perpendicular lines are opposite reciprocals of one another. So a little work on the side down here. If we have a slope of negative 2/3, the opposite reciprocal, we flip it. So it's going to be 3 over 2. And it was positive, so it's now going to be negative. So the slope of line C is going to be 3/2. So y equals 3/2 x. And then our y-intercept is negative 3. So we're going to do a minus 3 here at the end. Okay, that was slope-intercept form. Let's talk point-slope form. So now we have line D has a slope of 2, and it goes through this point. So we're given a point, we're given the slope, point-slope form. So let's write it out in general first. Y minus y1 equals m times x minus x1. and we're just going to plug in the pieces that we have. We know that our slope is the m value. We know that this point is our x1, y1. So our x1 is going to be 8, our y1 is going to be 9. So we'll plug in the pieces. Y minus 9 equals m times x minus 8. There we go. That's the equation of the line that has a slope of 2, and it goes to the point 8, 9. Of course, there's a mistake here. I just noticed. I put n in the final result. That should not be the case. This one has a slope of 2. My mistake. Okay, let's talk about line E. Line E is parallel to line D, and it goes through the point 11, negative 6. So again, we have the slope because we know these two are going to be the same. It's going to have a slope of 2, line E is, and it goes through this point 11, negative 6. So our 11 is our x1, our negative 6 is our y1. So when we write it out, it's going to be y minus our y1, which is negative 6, equals m, which is 2 times x minus 11, which is our x1. Of course, this can be simplified a little bit. If we subtract a negative number, it's the same as adding. So our simplified equation is y plus 6 equals 2 times x minus 11. Okay, here's our last one. Line F is perpendicular to line E, and it goes to this point 1, 2. So same thing, it's going to be point slope form. The only thing here is we actually have to find the slope this time. Again, let's do some work on the side here at the bottom. So if we had a slope of 2, that's the slope of line D and E, and we're trying to find the slope of F, which is perpendicular to 2. So 2 is the same as 2 over 1, and when you find the opposite reciprocal, you flip it and negate it. So 2 over 1 turns into 1 over 2, and it was positive, so it turns negative. So our slope here is going to be negative 1/2. So y minus y1, the y1 of course in this case is 2, equals negative 1/2, that's our new slope that we just found, opposite reciprocal, times x minus x1, which is just 1. So here we go, this is the equation of line F. Okay, if you have any questions, shoot me an email, and I believe you got this. I posted the answer key, so check your answers. Remember, don't just copy the answer key down, I'm looking for the process. So the answer key alone is not enough to earn you full credit, but I want to see the steps that led you to get the answers that I got. Okay, you got this, I believe in you, and shoot me an email if you have any questions.